So we're looking at section 7.3, solving exponents and logs. The first couple problems you're able to get like bases. So that's what we're going to do with this first one. 16 is 4 squared. That's being raised to the 2x plus 3. 1/4. Do you remember how that can be written? As 4 to what power? Yeah, -1, perfect. Right, -1, that's great. So 4 to the -1. And then that's to the 7x minus 1. Now, power to a power, you have to multiply that out. So we're going to multiply those powers together. That's going to give me a 4 to the 4x plus 6. That's my 2 times 2x plus 3. And then this guy over here is 4. -1 times 7x is a -7x, and -1 times -1 is a +1. And so now that you have the like bases, you can ignore the base and just take the exponents and set them equal to one another. So 4x plus 6 and -7x plus 1. And then solve it out. So if I take this 7, it's negative. I'm going to swing it over here, join up with the 4. They're going to combine to be 11. 11x's. And this 6 is going to come to the right. Join up with the 1, they become a -5. And so when I divide that out, I get a -5/11. And there's your answer. So that's no different than what we were doing back in the very beginning when we first started section 7.1. So if you can get like bases, go for it, do it, right? If you can't get like bases, then you've got to go into other avenues to be able to try to solve them, and that's what we're going to look at actually today. So take a minute and see if you can do number 2. Number 2 is a like base. You've got a 25 and you've got a 125. See if you can solve that for x by getting like bases on both sides. We good with 5, 6? Anybody? I mean, I know that we've seen these before, so. All right, well, let's go to something different, something that we haven't seen before. And that's the next thing here. Take the logarithm of each side. They're giving you a hint because you've got an exponent, and in order to solve that, when you can't get like bases, you need to use logarithms to be able to do it. So here's the deal. If it's an exponential function like this, I'm going to go to my margin here so you can see it. You want to isolate the exponent. In other words, the piece that's got the power on it, you need it to be by itself. The piece with the power on it is this 10 to the 6x. That needs to be by itself, which means the 11's got to go. So just like regular algebra thoughts, if I have 11 times this thing, in order to get the 11 out of there, I've got to divide by it. So to undo the multiplication, I have to divide. And 55 divided by 11 gives me 5. So 10 to the 6x equals 5. So you isolate the exponent piece first. Sometimes that takes you a couple steps to do it. But for now, for this one, it just took you the one little thing there. All right, well, I can't do like bases. like bases won't work because I can't write 10 as a power of 5, and so I'm stuck. So this is where the logarithms come in. And if you remember, one of the rules for logarithms is that you're allowed to bring the power down in front. So here's what it looks like when you take the log. The 6x, that power, comes down, and then you have the log of 10, your base, equals the log of 5. I want to say you've seen that kind of in the midst of doing our problems the other day. Then your task is, all right, we'll now solve for x. And so I think I would probably move the log of 10 first. So 6x equals log of 5 over the log of 10. Let's go to our handy dandy calculator and figure out what that is, right? So if I were to do that, is anybody having a hard time in their calculator finding these pieces? I think we did talk about that too as we were in the other sections, but all right, you should get 6x equals, if you divide this, log of 5 divided by the log of 10, I believe you get, if I round it, 0.699. And so when I divide by 6, I get my final answer, which is 0.116. Check me out, make sure I got it right. Thank you. I appreciate you having my back. There you go. Okay. Number 4 is done the same way. So if I look at this, I need to isolate the piece with the exponent. Well, that's the 14 piece, right? So I've got a 9 that has to go, and I have a 7 that has to go. And think about which one you would move first. Would you move the 9 or would you move the 7? You're undoing a please excuse my dear Aunt Sally, so you're going backwards, which means that you would be adding or subtracting first and then doing the division or multiplication second. So you're undoing a please excuse my dear Aunt Sally. The first guy to move is the 7. So if I take 7 and subtract it away, now I have 9 times 14 to the 9n plus 8. Take 7 away, that gives me 90. And then I can get rid of the 9 that's in the front. And just like the last problem, if it's attached by multiplication, I'm going to undo that, and that's going to put me at dividing. So dividing 90 by 9, here I am now, 14 to the 9n plus 8 equals 10. And again, think like bases. I can't do like bases. There are no like bases with 14 and 10, so I've got to do my logarithm stuff. So the power comes down in front, 9n plus 8, log of 14 equals log of 10. Maybe you might even want to, just for the sake of confusion, non-confusion, put parentheses around that power, because it's not just the 8 that's attached with that log, it's the whole power there. Okay, so let's divide by log of 14 and figure out where we're at. If I take 9n plus 8 equals the log of 10 over the log of 14, I'm going to go to my calculator and figure out what the decimal value of this is, so I can work my way to get what n is. All right, here goes. Log of 10 divided by log of 14. Toss it in the old calc. You end up getting 0.873. And then it's just like a regular old little algebra problem. So you're going to take and subtract 8 and then divide by 9 to figure out what n is. I'll give you a head start. See if we match. Awesome. Yes. Yeah, I'm seeing some answers there that are with me. Negative 0.792. Perfect. All right, so we saw so far solving exponents when you can get like bases. We saw when you have to solve exponents and can't get like bases. That's your process. Now they're going to look at solving logarithm problems, and kind of the same idea applies. You need to isolate the logarithm first before you do anything else. So isolate the log. Now that could be an log, it could also be an ln. You'll see number 5 is an ln. You can't do the solving that you need to do until you get that by itself, the logarithm and the term that has a logarithm in it. So here's my guy with the logarithm. I need that by itself, which means the 5 has to go. So if I'm taking that 5, if I'm a minus 5 right now, I'm going to add 5 onto the other side. So here's where I'm at next. ln of x minus 6 equals 9. And just as we talked about before, if I'm trying to solve, just like with this guy up here, the exponents, in order to solve an exponential equation, I need to use logarithms. In order to solve a logarithm equation, I need to use exponents. So I'm going to use the exponents to do this. And you haven't seen this for a little bit, it's been a few days, but this is the loop-de-loop. We're going to take whatever the base is, I'm going to go through the 9 and stop at the x minus 6. Remember the loop that we talked about before? But this one has an invisible piece that you need to remember. Starts with the base when you do your loop. So if I start with the base, there is no base. It's invisible. There's nothing there. So I have to think about that for a minute. Well, it's an ln. If it were an log and there were no numbers there, it would be a 10. You're right, Bella. This one is an e, right? ln has an e. So there's an invisible e there. And if I were to rewrite this as an exponent, it would be e to the 9th equals x minus 6. So remember how that loop works. It makes it pretty easy just for you to set up that exponent. And then honestly, just go to your calculator and figure it out. So go to your calculator, figure out what e to the 9th is. Equals x minus 6, and then solve for x. So I'll give you a chance to get a head start on that. Where is E? That is a good question. Okay. Deb, I'm assuming that you are using those blue calculators. Do you have a second PRB? No, you're not. Which calculator are you using, babe? The graphing one. Okay. Then the graphing one I actually can show you. Hold on. All right. Okay, so if I want to get to E, it is second, and then it is the ln button next to the 4. Second, and then, yeah, the ln button next to the 4, and that should give you the E with the caret, and so that can help you out with your E to the 9th. And then from there. Anybody else haven't calculated? Like, you haven't seen these buttons before, so it wouldn't surprise me if you. And another great question: what's the difference between log and ln? And it's totally the base. The base of an log is 10, and the base of an ln is e. Really, that's the big difference. They're both treated the same way. Like all the properties that go for logs work for ln's. And vice versa. But really the difference is what the base is. Probably in the world of bigger math, it's the ln's that they use more often than the log's. But that's your big deal, just what the base is. They perform the same way. They're the same. Yeah, it doesn't surprise me that they're the same button. They're very, 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 excuse me, they're very, very similar. And they're treated the same way, and you work with them the same way. It's just a matter of what the base is. All right. So, middle guy. If you treat the middle one, number 6, the same way that we just did the other one, I want to get the log piece by itself. So the log base 2 of b, which means that the 7 has to move. So 7 moving goes to the other side and becomes a negative 10 when it joins up with the negative 3. So I've got the log base 2 of b equals a negative 10. All right, you've isolated the logarithm. Now you want to change it into an exponent. So you're going to do your loop. Loop-de-loop. That's going to give you 2 to the negative 10 equals b. And then you just go to your handy-dandy calculator and figure out what 2 to the negative 10 is. It's teeny tiny. Now the concept doesn't get any harder. You're just isolating the logarithm and then changing it to an exponent to solve it out. So although number 7 looks all beastie, it really isn't that big a deal. You are going to get this log piece, log base 3 of n minus 10 by itself. You've got a negative 5 that's in your way, and you've got a negative 7 that's in your way. And so the first thing you want to do, like I was saying before, you're undoing a please excuse my dear Aunt Sally, but you're going backwards. So you're adding or subtracting first, which means I'm taking this 5 and moving it over here. That's going to give me negative 7 log base 3 of n minus 10. When I bring this over, that gives me a negative 7. And you can see kind of how it lines up pretty, because next thing you want to do is divide by this negative 7 that's in the front. And that's going to give you a 1. So here I am, log base 3 of n minus 10 equals 1. You have isolated the logarithm. Now you're going to loop, turn it into an exponent. Gives you 3 to the first is n minus 10. 3 to the first is 3. Bring this 10 over, so you've got 13. And there it is. All right, so you get down to numbers 8 and 9, and they are back to solving exponents. So I'll give you a chance. I'm going to give you a couple minutes. See if you can do numbers 8 and 9. Solve for x. Scotty, that's a great question. Because you have an E, yes, you need to use ln. So E's always go with the ln's, not L or G's. So yeah, that's a really good question. When you get down to taking the log, it's going to be an ln question. That is true. Good thinking. By the way, for some of these, there's more than one way to approach it, but our answers should be the same in the end. So if you approach it one way and I approach it a little differently, that's okay, as long as we get the same answer in the end. And good question too, Lily. It is understood to be E, so you don't have to write. It's kind of like 1x. You can write the 1, you don't have to write the 1. It's understood to be there. So with ln's, you can write the E, you don't have to write the E. It's understood to be there. So yeah, it's invisible. So whatever makes you happiest, if you want to put it in there or not. All right, so let me help my struggling child and other children. I'm sure you're not alone. First thing you want to do is isolate the exponent piece. So that's this guy. And so that means that I am going to take that 7 and I'm going to subtract 7 from both sides. So that gives me negative 3 e to the negative x equals, and then 2 minus 7 is a negative 5. But again, I need to get this exponent piece by itself, the e to the negative x, so the negative 3 has to go. And so I'm going to divide by that. So my next step is e to the negative x equals negative 5 divided by negative 3 is a positive 5/3. All right, so now you've got it isolated, and now you need to use your logarithm to be able to solve it. So the power comes down in front, negative x. Because it's an e, you're going to use ln, not log. ln of e equals the ln of 5/3. Well, if you go, excuse me, if you go to your calculator, ln of e, try it. The ln of e to the first is 1. This just equals 1. Because ln's and e's undo each other. And so that value is just 1. So really what you have is a negative x equals the ln of 5/3. So go to your handy dandy calculator, figure out the ln of 5/3, and then divide by -1. And that's going to be your answer. So remember, you don't want a negative x, you want what x is. So when you divide by a -1, you should get -0.511. Why did I do 2 ln's? Let me go back up to number 3 when we did the same type of thing. Yeah, I was saying that, Lily, too. You could definitely approach this differently than I did, but as long as you get the same answer in the end, you're good to go. So the reason I got 2 ln's is the same thing why I had 2 LOGs. It happened to be up here. So you take the power down in front. In this case, it was LOG of 10, LOG of 5. This one is the same idea, but it's ln's. So power comes down in front, ln of E, ln of 5/3. So same concept for this guy. And then when you go through and solve it, you end up with that -0.511. Okie doke. How about number 9? Have you had time to do it? Need a minute. If it's any help, I approach this one with like bases. Is that the only way to do it? Absolutely not. But that's kind of the approach that I took to this one. Okay, question number 1 is, how did I get this 16? So I took this, remember how you're supposed to get the exponent piece alone by itself? Mr. 32 had to go. And so Mr. 32 is attached by multiplication to this. So to undo that, I had to divide. So 2 divided by 32 gave me 1 over 16. Oh, the 32's hanging out there, yeah. There's so many different numbers doing so many different things in these questions, so it doesn't surprise me that sometimes you can overlook some parts to this. Okie doke, an answer of 6, do we like it? We're going to talk about, are we ready to flip the page? Slow me down if I need to slow down. But flipping the page is a bunch of word problems. And actually, you'll see the last page in the packet gives you a whole bunch of different formulas that deal with logarithms and exponents. And these are more, I want to say these are more science-oriented questions, like Newton's law of cooling. Kind of a cool formula that he came up with, Sir Isaac Newton. But it's about, like, did you ever heat something up in the microwave, like soup or something like that, and it's too hot for you to eat, so you throw it in the freezer? Anybody else do that? Right? So you're trying to cool it down. It's like, how long will it take to cool down to a reasonable temperature for you? That's this Newton's law of cooling. So it has to do with what the surrounding temperature is and what the temperature of your soup or the object is. There has to be a cooling constant, that's the K, and then an amount of time that you're leaving it in there for. So Newton's law of cooling, kind of cool. We're not going to deal with it. Second one that they have is decibel levels, like for sound. So there's a formula that they're giving you here for decibel levels dealing with sound, and you can see that's this formula with the logarithm in it. Then earthquake intensity, a Richter scale, he has a logarithm. So if you are someone that is interested in figuring out earthquake intensity, you're going to be using logarithms for that. Rocket science, if you're someone with rocket science, you're using LNs. Half-life, I think you might have seen that in science at some point in time. Half-life formulas are exponential formulas, exponential functions. Again, a science thing of carbon dating. The next one down is carbon dating. That one deals with exponents again, with e's, raised to powers. The ones that we are actually going to look at and keep on our radar, because they're not so sciencey, are the compound interest formula, which we saw already when we were back in section 7.1, and the continuously compounded, the PERT formula. These two are ones that we're going to actually keep up with. The packet does word problems with all of these different types of things. We're going to skip that. We're going to keep it consistent just to money and compound interest, and whether it's compounded continually or compounded like daily or whatever that might be. All right, so going back to then where we put the page. First one is Newton's law of cooling. We are not going to do Newton's law of cooling. Actually, I can tell you the answer, because some of you, if you are interested in this kind of stuff, I'll tell you what the answer should be. It's 5.17 minutes. In case you feel like doing these problems, I'll just tell you what the answers are. Number 11, this one is talking about an atomic bomb. And this one, the magnitude, your M, is going to equal 6.485. But number 12 is one I actually want to do. So let's take a look at number 12, because that's now money. And it's kind of neat because you've seen these before, but the way that the term that you're solving for this time is not the final amount. You're given, you don't have to do these, yeah. You do not. The only one, like the one, number 12 is a yes. We're going to do that one together. And I'll explain as we get to the homework pages, the practice problems, which ones you can and don't have to do. The only ones word problem-wise that you have to do are anything involving compound interest or continuously compounded interest. So any of those types of banking questions, yes. But any of the ones that deal with atomic bombs and magnitudes and Newton's law of cooling, you do not have to do. So we'll be more specific when we get to those practice problems. But for this guy, how many years will it take $5,000 to amount to $8,000 if it's invested at an annual rate of 9% compounded continuously? All right, so there's a few pieces of information that we have here. First thing I have is this compounded continuously. As soon as you see that word, you know you're using the PERT formula versus the P times the parentheses 1 plus R over N to the NT power. Anyway, there's two formulas, but this one continuously is the PERT guy. Well, you start out with $5,000, you end up with $8,000. So this time they're telling you what you end up with. You end up with $8,000. You started with $5,000. E is E. How about your rate? Do you remember how the rate goes? It's 9%, but I don't use 9. You've got to use the decimal of that, so 0.09. And the question is how many years? What is t? You're trying to find t. Now this is just like solving the equations that we were doing back on the front page. I need to isolate the exponent piece. In other words, I need to get rid of that 5,000. 5,000 is attached by multiplication, so I'm going to undo that and divide by 5,000. And so when I do that, 8,000 divided by 5,000, I get 1.6 equals e to the 0.09 t. Remember how this works? If you've got the exponent isolated, you need to now turn it into a logarithm. Exponents go to logarithms. So I'm going to take this log on this 1.6, and I'm going to use ln's because it's an e. So the ln of 1.6 equals, bring the power down, 0.09 t ln of e. And so ln of e, remember I said earlier that's 1. So you can just, you don't need to worry about that. You can ignore it. So you go to your handy dandy calculator and you figure out, well, geez, what is the ln of 1.6? Oh no, take a minute and find it. And then divide by 0.09. And that'll tell you how long it's going to take you to leave that money in that account so that it can earn $8,000. By the way, it's unheard of to get 9% interest, so in the real world, that probably is not happening. If it is, if you find it, do it. Put lots of money in there. So ln of 1.6 divided by 0.09. And that should give you your time. And it should take you 5.222 years to go from $5,000 to $8,000. When we did these problems before, the only things that we could solve for were like what the final amount would be after you've invested it. Now that you know how to solve logarithms and exponents, you can now figure out this time value, how long it takes for it to get to that place. All right, number 12 is good. Number 13, archaeology, carbon dating, we are not doing. The answer, if you are interested, oh my goodness, the answer. This one is 50,117.807 years. That's nuts. So if you do want to go ahead and if anybody's interested in those things, that's the answer. And then we are flipping the page again. And we're looking at some more of the basic problems that we've been talking about. There are a few on here that I want to look at together because they're different than the examples that we've done so far. So a lot of them are the same. A lot of them are you're doing the same type of thing. But some of them bring up stuff that we haven't talked about. Oof, I'm looking at the ones I want to pick. It says, direction-wise, it says, solve rounding to 3 significant digits. 3 decimal places, okay. First one that I want to look at is number 8, because number 8's a little bit different than things that we saw on the front page of examples. I need to isolate the logarithm, right? That's what the deal is. Well, I've got 2 of them. That's a bit of a problem. So I can't just isolate it because I've got 2 of them. But what I can do is use my rules for condensing to be able to put these 2 things together in a condensed form so that I have 1 logarithm, and then I can solve the problem. So see how this one's different? There are 2 terms that have log in them. We didn't see that on the front page. So for this one, we want to take those LOGs and we want to condense this into one LOG problem. So LOG, there is no base, it's understood to be 10. And if I see a plus sign, that means I have to be multiplying the pieces. So that means I'm going to have an x times an x minus 3. Do you see how I did that using condensed? Now I've got the singleton log, and now I've got it isolated. So all I need to do is do my loop-de-loop and see what it looks like. So invisible 10 goes through the 1, stops at the x times x minus 3. Looks like this. 10 to the first equals x times x minus 3. And in that itty-bitty font there, it says check for extraneous solutions. Remember how they work? Extraneous guys are ones that you solve for, but they don't work when you plug them back into the problem. So we're going to have maybe possibly some extraneous with this guy. All right, this at this point is going to be a regular old algebra question. So if I have 10 to the first, that's 10. X times x is x squared. X times negative 3 is negative 3x. And my job is to solve for x. So I can tell I'm going to have two answers for x. I'm going to have to factor. I'm going to bring the 10 over so everybody's on the same side, and I can think factoring. X squared minus 3x minus 10. Two numbers that multiply to give you negative 10 and add to negative 3. Gives you answers that are x equals 5 and x equals negative 2. So here's one of the rules for logarithms, again, that hasn't been talked about, is that you can't take, I'll put it up here, you can't take the log of a negative number. It's impossible. You get undefined values. So you can't take the log or natural log of a negative number. That's what this extraneous thing is talking about. So if I go back up to the original problem and put a 5 in here, the log of 5, that's positive, that's fine. This would be the log of 5 minus 3, this would be the log of 2, that's fine, no issues. If I put a negative 2 in though, the log of negative 2, you can't take the log of a negative number. That's where this extraneous thing comes into play. So this guy is extraneous. Can I fit it in there? He's your extraneous guy. You can't take the log of a negative. All right, we are getting close to done. Number 10 is another Wallapalooza. So I want to look at number 10. Same thing goes. Look at this guy. He's got an ln on the left and he's got two ln's on the right. So I need to condense that down into, I can leave an ln on one side and an ln on the other side. I just can't have three of them. So these need to combine together. So on the left, I still have an ln of x. And on the right, subtraction means division. So this guy's going to be the ln of 2x minus 1 over x minus 2. Remember, when you're condensing these guys, you only write that ln or the log or whatever it is once. Okay, again, a different approach for this one, because you see how you've got an ln on this side and an ln on the right, left and right. Well, the ln of this equals the ln of that. What do you know about this and that? They have to be equal in order for them to be the same. So I can totally, because I've got an ln on both sides, I can cancel that and ignore it. And what I'm left with, and that only works if you've got it on both sides. So I have then x equals 2x minus 1 over x minus 2. And now I'm back to an algebra problem that I'm trying to solve for x. So let's see where it takes me. I'm going to go into the space of number 12, just so you can see me writing. All right, take the x, put it over 1, cross multiply, however you want to look at that, but I tend to think cross multiplying. So 2x minus 1 times 1 is 2x minus 1. X times x minus 2 is x squared minus 2x. And so then I'm going to set it up and hope that it factors. So I've got x squared. I have a negative 2x over here. I'm going to join another negative 2x, so minus 4x. And then I'll have a plus 1 when I bring that 1 over. And I look at that and I'm like, really? That guy's never going to factor. And so what are my options? My options are, unfortunately, the quadratic formula in order to get my answers. So let's see. If I use quadratic formula, I'll keep going down here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, 16 minus 4 is 12. So really what I have is x equals 4 plus or minus the square root of 12 over 2. Now, don't get all crazy. Leave it just like that and put it in your calculator. So in your calculator, what you want to do is put 4 plus the square root of 12 equals, and then divide by 2. And then you want to do 4 minus the square root of 12, and then divide by 2. It's going to give you two values with decimal points. So I'm going to give you a head start. See if you can find me those two values. Oh wow. Okay. Let me give you some directions for where we're going to go, so that I know that Deb's got to get a move on to get out of there on crutches there. Turns out that this 0.267 number is extraneous, because if I put it in here, think of it as like 0.3. 0.3 minus 2 is going to be a negative number. So this guy here is your extraneous, and your final answer for this problem, number 10, is 3.732. Let me show you what I want you to do. So your h-dubs is everything on the front page that we didn't do. Okay, so you can do all of the rest of these problems. I did the hardest ones there with numbers 8 and 10. So you're going to complete those up to number 12. You know, if you flip the page, you know how to do numbers 1 and 2 on that application page. But you do not have to do anything else on that page. So just numbers 1 and 2 on that page. And then one more flip. Only number 10. Only number 10 because it's one of those compounded interest questions. You do not have to do 7, 8, or 9. Did you catch all that? Okie doke. I have that due for tomorrow night, I think. No. What's today? Tuesday. For tonight, maybe you can help me out if you're looking at our, I guess I can pull it up too. I'm just checking out our calendar to make sure I'm telling you the right dates. All right. Actually, I don't have it due until Thursday. Are you watching? Let me share my screen here. All right, so Monday we did this, or I'm sorry, Tuesday we did this. Notes on section 7.3, we got that. Tomorrow, our optional time, I'm going to answer questions from anything in Unit 7. Thursday, you are finishing anything, it's really 1 through 12, but then it's the ones that we circled, you know what I'm talking about. There's a couple extra questions in there. And then when we're together again, we are going to do a worksheet on section 7.3. Don't forget your mastery check. You want to be working on that. I believe that puts us at a test probably next Friday. So we'll review on Tuesday, the following week. Next week. We'll review on Tuesday and have a test on Friday. So that's where it's going. Any questions on, so you don't have anything due until Thursday for this? All right, questions for me, anything? So I'll see you Wednesday if you have questions on anything from Unit 7, and otherwise I will see you again on Friday. Have a lovely day. Thank you guys for your well wishes. I'm working on it.